One important concept that can help you address the needed improvements in your product in order to be able to make your products accessible or easy to manufacture is the idea of mistake proofing. In this lesson, we will talk about mistake proofing in terms of what it is and examples of mistake proofing in the context of products and of processes. Mistake proofing, also known as poka-yoke, is an approach or a way of thinking by which we can design something in a product or process or even in our procedures that will physically or procedurally prevent a person from making an error or a mistake. A good example of poka-yoke would be the shape sorter that you may have played when you were a kid. If you want to help the child be able to recognize shapes, you could have a device that allows you to only insert the right shape on the right hole. Oftentimes, we use the word errors and mistakes almost interchangeably. Errors or mistakes are not necessarily bad, although people often look at them as bad. Mistakes are something that we do based on a decision we did consciously and turns out to be wrong. Error, on the other hand, is something that inadvertently you did not anticipate, wasn't expected, and oftentimes, when we look at mistakes and errors, we either look at them as something that's unavoidable or maybe something that could be avoided. Generally, when you talk about errors or mistakes, there are often many kinds of them. You can look at them as something that you forget, or maybe you misunderstood or misidentify, or because you're inexperienced, you were not able to anticipate it. It could also be willful, which can be intentional in its essence. It could be an inadvertent or something that you did not expect to do or happen. Judgment based on something you believe and turns out to be a mistake. No standards, therefore you allow people to try to do things on their own, or there could be unexpected situations or purely intentional. When we try to look at these errors or mistakes, they often appear as defects in your products or processes. And defects can be in the form of something that was omitted, meaning was not done. It could be an error in the actual work that was done, like a processing error. It could be error in the setup, or there could be missing parts or wrong parts were used. Or maybe the processing was done in the wrong place or in the wrong form. There could be a misoperation. The way the work was done is totally wrong. There could be some adjustment error, or maybe the equipment that is being used is not set up properly, or the tools and jigs used are not sufficient for the work to be done. In general, when people hear about errors and mistakes, the most common reaction was to have inspection built into the process. And inspection can come in the form of sampling, to just take a few observations out of the many possible observations you can get, or it can be 100% inspection, which can be very costly. in order to be able to address these errors or mistakes, oftentimes when inspection is done, we hope that we could detect the errors and mistakes or even failures. And detection can happen in many parts of the process. Hopefully, we get to detect the error from the source where it actually emanated. So that's our source detection. But it can also be self-detection, which is error detected during the operation or use. Or it could be after the operation, which is after the fact, and that can only be done in terms of a successive detection, meaning after you've done the work. Our goal or objective in doing mistake proofing is to be able to design something on the product or the process so that mistakes can be detected and corrected immediately so that defects are prevented. When performing mistake proofing in your product, you can start by identifying what are the key processes or operations that are needed to be able to make your product, or in this case, be able to manufacture or assemble your product. We now apply the 5 whys in trying to find out what could be some of the cases in your processes where it will fail in making the product or can cause a failure on your product. There are 2 approaches you can use when you try to think about how to address failure. The first approach is what we call the shutout type, which is how can we prevent the error from happening, whether in making the product or in using the product later on. The second approach is the attention type, where you actually highlight the idea that the failure, if it happens, when it happens, should be detected immediately before it gets worse. When we talk about using these concepts, we can apply different techniques in Poka-yoke, which we'll discuss later. Second, we need to also look at how errors can be created, and oftentimes these can be in the form of either a contact, meaning there was touch, or a constant number that happens, meaning something that happens often in your process, or it can be related to the sequence by which you do the work. So these are 3 clues in which you can investigate how you can inject Poka-yoke in terms of where things come in contact, in terms of how often things happen, or in the sequence by which you do the task. Once you've identified these 3 concepts and how you might want to intervene them, you can test your new method and see how it works. And then finally, you need to make sure that the persons who will be applying these methods in your processes, whether manufacturing or assembly, would be able to do them well. When thinking about Poka-yoke in your products, you might want to consider a hierarchy of how you would design or redesign your products. Oftentimes, when a product is not really well designed and doesn't seem to address the needs of the main customer, or in this case, so difficult to make, you might want to go and start by redefining the use of the product. Changing it is going to be very difficult. The next step is you might want to restrict the use of the product in terms of how often you use, or when you use it, or where you use it, so that the product becomes capable of delivering or performing. The next level, which is what we call the indirect safety means at the third most level, is when you try to do some safeguarding so that when they use it, it will still not allow people or machines to make mistakes. And finally, is to fully design into the product so that it becomes safe and easy to use and manufacture. A common example of designing Poka-yoke into your product is to look at this very simple connector between two plugs, a male and a female plug, where if you look at the way the plugs are connected, you won't be able to make the mistake of plugging them to the wrong cable or outlet because of the way the connectors are shaped. This prevents people from unnecessarily creating a terrible mistake or, at worst, destroy the product itself. In this example, you probably have had this chance when you go into an airline and you check in and they will ask you to make sure that the luggage you carry on is going to be the right size so that it will fit in the luggage compartment in their aircraft. When staying in a hotel, you probably had the chance to use a hair dryer, and oftentimes the hair dryer could be attached to the wall and you have a hard time returning the hair dryer in its proper position. In this case, you have a mechanism that allows you to put it back without worrying about whether it's in the right place or not. How often have you parked in a space where another car seemed to have veered off or gone out of their own area? Here's an example of a parking space that if you go outside of your area, your car would not be on the flat ground. A common example of a pokayoke applied in a drive-thru is what they call a bang bar, or a bar that prevents from any oversized vehicle from going through it and experiencing bumps and dents or damages in the property. And yet in another fast food restaurant, you could have seen trays by which customers used, and oftentimes these trays are going to be self-returned, or the customer needs to bring it back to an area for which you bus your own table. But oftentimes some of these trays end up in a garbage chute. So to prevent from the trays getting into the chute, you now have a pokayoke hole that no matter what you do, the trays won't be able to fit in. Nowadays, you can see a lot of malls having this kind of a system where you can see lights that tells you parking spaces are available, and thus you don't need to go around and find them. These things are now more ubiquitous than ever. When doing pokayoke in processes, we need to make sure that we are aware of what are the common errors that you encounter when you try to error-proof your own manufacturing or service processes. This can be in the form of processing errors, or setting up error, or a process that can result to missing parts, or improper parts or items being used, or there's an operation error when it was carried by the person, by the operator, or more commonly, errors in measuring or adjusting. Here are 5 best pokayoke rules being recommended. 1. Use guide pins in your processes so that you don't have to find a way to adjust them. 2nd, you can use an error detection alarm when things are not right. 3rd, we can use limit switches, meaning it controls the way or how much force you apply, or how much electricity or how much effort you put in. You can also use counters so that you don't have to forget about how much or how many times things have been used or consumed. And finally, you can use a checklist to remind the person what you should do in case you have situations or scenarios in your plant, or allows the person to make sure that the activities to be done will be standardized. Common examples in manufacturing would be to use color-coded cables to make sure that there will be no wrong connection when there are times you need to prepare or set up your equipment. You can also use guide pins, or what we call interference pins, so that when you put two parts together, or when you try to put a mold together, that there's no way to get it wrong or put it the wrong way together. You can also use a very simple mechanism where auto rejection happens on the wrong part because of its position. As you notice in this example, if the orientation of the part is wrong, it will automatically fall off your guide rail or your conveyor system. Another example of a sorting process is by shape. You have a shape that's longer or bigger or different than the others, and therefore the different shape will go to another bin or another area. So it lessens the chance of using or having the wrong part at the wrong place. You can also use an automatic sorting by size, where the bigger sizes will often fall off early and the smaller sizes will be classified at the very end. And finally, you could have a sorting by content with some sensor so that you know that an object is filled up or not. One classic example of a sorter that tries to check that the package is filled is to put a fan, and if the object falls away, that means that particular package is empty. In summary, Poka-yoke can be applied in any process, industry, products, or services. And the benefits you get are as follows. It helps the work or the process to be done right the first time. It is capable of making sure that mistakes will not happen. It is not costly because oftentimes the solutions are very simple and practical. The application of Poka-yoke gives you immediate feedback, and thus actions can be taken immediately to prevent the defect from happening. Some key messages that I'd like to end for this lesson. Number one, designs let people make mistakes, not people. For organizations to be effective, it is not enough to have signs or warnings or even exhortations. You have to error-proof your organization. And finally, Poka-yoke technique is one of the most precious gems in lean management, and it is often used to ensure that quality can be achieved by preventing defects in the first place.